The effects of one eye versus two eyes on information processing when completing the Fitt's task. This video is going to cover a brief overview of the introduction. We'll be talking about the information processing theory, the task that we've completed, manipulation we've chosen and why we've chosen this manipulation, the procedure of the experiment, and the controls we've put in place. Then we'll be discussing the results as well as the implications and recommendations. The introduction. Hicks' law describes the time taken for individuals to decide based on possible choices they may have. For example, by increasing the number of choices, this will increase their decision time. The law assesses an individual's cognitive information capacity in choice and reaction time experiments using measurements of bits. A bit is information that reduces individuals' initial uncertainty by half. The time taken to process a certain number of bits is known as the rate of gain of information. Furthermore, Hicks found that the reaction time had almost a perfect linear relationship between the amount of information to be processed and the time taken to respond. This strategy has been replicated in many studies and will be demonstrated in our fixed task experiment. The information that we gather from our environment is being constantly processed. However, the capacity of our information processing system is limited. When we are processing information from the world around us, the system is being used up. Our performance is related to that system's ability to extract information from the stimulus display. This is known as the information processing theory. Additionally, it suggests that errors will occur when demands of information processing systems exceed the capacity to process that information from the stimulus. To examine this theory, we conducted a Fitt's task experiment to measure someone's processing ability on a perceptual motor task.
For our experiment, we had a baseline and a manipulation. Our baseline was completing the task with two eyes, and our manipulation was completing the task with one eye. So why did we choose this manipulation? We hypothesized that two eyes would have a faster reaction time in processing information when demands of the task gets harder compared to one eye. We are expecting to find that with one eye covered, this will increase difficulty of the task as one eye will now have to compensate for the second eye that is not in use when processing incoming stimuli, therefore resulting in a slower reaction time in comparison to having two eyes. Additionally, we also selected this manipulation for practical reasons because of cost and time constraints, therefore making a convenient choice for our experiment.
The procedure was a true experimental, repeated measures or within groups design, where the participants take part in every trial of the Fitt's task. Prior to the commencement of the experimenter used a randomizer website in order to randomize the trials in each condition. The website generated an overall number of 30 randomized trials based on the 6 levels of difficulties, or the condition, across 5 trials to estimate the baseline measure. The same process was used to generate and estimate the manipulation measure. Overall, there were 60 trials in total. In addition to an experimenter, there will be an independent timer who will time the participants throughout each trial in each condition, from the time they commence the task right to the end. The timer will then record participants' total time in a separate recording sheet provided by the experimenter. The participants were first given a pen and instructed to sit on a chair with no part of their body touching or leaning towards the table in front of them. The target sheet, which corresponds to the level of difficulty in the trial as stated by the randomizer, was placed in front of the participant and secured with sticky tape to ensure no movement and inadvertent distractions for the participants. The target sheet was placed with the start box facing the participant at the bottom of the page, and the participants were instructed to hold a pen with their dominant writing hand with the tip placed within the start box. Experimenters begin each trial saying, "When I go, please tap quickly between the circles as quickly and as accurately as possible. Tap first in the bottommost target and continue upwards onto the remaining targets, progressing up the page. An accurate response is the one that hits inside the target area. If you miss the target area on more than one occasion, you will be asked to repeat the trial. Each condition will be preceded by a practice trial. Experimenters begin each trial by saying, "Are you ready?" followed by "Go." When the subject hears "Go," they tap inside each target, moving up the page in a zigzag fashion. Experimenters should ensure that each participant completes each trial in each condition and is performed as quickly and accurately as possible. For the manipulation trials, participants do the same thing, except they are required to cover one eye with their non-dominant hand, then complete the task.
Our experiment included various controls. Controls included those designed to eliminate systematic errors as well as random errors. Equivalent test conditions for all participants were ensured by every participant completing the test in one sitting in the same room on the same day. The test location chosen was a room booked out at the Curtin Library. This location was decided upon due to its minimal noise and distractions. As stated above, participants weren't allowed to touch the table with their hands or elbows, further standardising the test conditions. Randomisation in the order in which participants carried out each condition was achieved through the use of a random number generator. Randomisation in role allocation was ensured by selecting names from a hat to choose who would start as an experimenter, participant or timer. This was required in order to control for ordering effects. The roles of experimenter and timer were separated in order to allow timers undivided focus on the time taken on the task and using the stopwatch, while the experimenter could apply their undivided attention to the accuracy achieved by the participant in hitting the inside of the circle and not any other part of the paper. Other controls were designed to minimise errors and extraneous variables associated with the materials used in the experiment. These included every participant using the same instrument to hit the circles, big ballpoint pen, and sticky taping the piece of paper containing the Fitt's task circles to the table so performance could not be influenced by movement of the paper. To ensure fairness, participants all used their preferred hand to complete the task. During the manipulation phase, this required participants to cover up one eye with their non-preferred hand.
Now we will be discussing our results.
This is the regression equation we need to consider when looking at our results.
For the baseline, the slope is 68.229 and the intercept is 82.571. When considering the regression equation for the baseline, y equals 68.229x plus 82.571, and the R-squared value is telling us the model explains 95.4% of the variability of response around the mean. When looking at the rate of information processing, for baseline, 14.657 bits of information is processed in 1 second. For the manipulation, the slope is 141.97 and the intercept is negative 59.571. The regression equation for the manipulation, y equals 141.97x minus 59.571, and the R-squared value tells us the model explains 96.1% of the variability of response around the mean. When looking at the rate of information processing for the manipulation, 7.044 bits of information is processed in 1 second. For the baseline, the slope is 75.286 and the intercept is 26.214. When considering the regression equation for the baseline, y equals 75.286x plus 26.214, and the R-squared value tells us the model explains 92.2% of the variability of responses around the mean. When looking at the rate of information processing for the baseline, 13.282 bits of information is processed in 1 second. For the manipulation, the slope is 165.03 and the intercept is negative 178.93. When considering the regression equation for the manipulation, y equals 165.03x minus 178.93, and the R2 value tells us the model explains 94.4% of the variability of responses around the mean. When looking at the rate of information processing for the manipulation, 6.060 bits of information is processed in 1 second. For the baseline, the slope is 35.531 and intercept is 154.5 35.53 when considering the regression equation for the baseline y equals 35.531x plus 154.53. And the R-squared value tells us the model explains 67.2% of the variability of responses around the mean. When looking at the rate of information processing for baseline, 28.144 bits of information is processed in 1 second. For the manipulation, the slope is 164.78 and the intercept is negative 161.56. When considering the regression equation for the manipulation, y equals 164.78x minus 161.56. And the R-squared value tells us the model explains 88.3% of the variability of responses around the mean. When looking at the rate of information processing for the manipulation, 6.069 bits of information is processed in 1 second. For the baseline, the slope is 71.514 and the intercept is 128.79. When considering the regression equation for the baseline, y equals 71.514x plus 128.78. And the R-squared value tells us the model explains 97.4% of the variability of responses around the mean. When looking at the rate of information processing for the baseline, 13.983 bits of information is processed in 1 second. For the manipulation, the slope is 92.914 and the intercept is 58.286. When considering the regression equation for the manipulation, y equals 92.914x plus 58.286, and the R-squared value tells us the model explains 95.4% of the variability of responses around the mean. When looking at the rate of information processing for the manipulation, 10.762 bits of information is processed in 1 second.
Implications and recommendations. In regards to participant 1's result, the slope of the baseline suggests that each bit of information requires 68.229 milliseconds to be processed, while the slope of the manipulation suggests that each bit of information requires 141.97 milliseconds to be processed. The intercept of the baseline, however, suggests that the reaction time is 82.571 milliseconds when there is no uncertainty, thus 0 bits, while the intercept for the manipulation suggests that reaction time is negative 59.571 when there is no uncertainty. For participant 2 results, the slope of the baseline suggests that each bit of information requires 75.286 milliseconds to be processed, while the slope of the manipulation suggests that each bit of information requires 165.03 milliseconds to be processed. The intercept for the baseline, however, suggests that the reaction time is 26.214 milliseconds when there is no uncertainty, thus no bits, while the intercept for the manipulation suggests that the reaction time is negative 178.93 milliseconds when there is no uncertainty. In regards to participant 3 results, the slope of the baseline suggests that each bit of information requires 35.531 milliseconds to be processed, while the slope of the manipulation suggests that each bit of information requires 164.78 milliseconds to be processed. The intercept for the baseline, however, suggests that the reaction time is 154.53 milliseconds when there is no uncertainty, thus no bits, when the intercept for the manipulation suggests that the reaction time is negative 161.53 milliseconds when there is no uncertainty. Participant 4 results. The slope of the baseline suggests that each bit of information requires 71.514 milliseconds to be processed, while the slope of the manipulation suggests that each bit of information requires 165.03 milliseconds to be processed. The intercept for the baseline, however, suggests that the reaction time is 128.79 milliseconds when there is no uncertainty, thus no bits, while the intercept for the manipulation suggests that the reaction time is 58.286 milliseconds when there is no uncertainty. For participants 1, 2, and 3, the slope suggests that the manipulation of completing the task with one eye had a slower rate at which uncertainty is resolved compared to the baseline, which is completing the task with two eyes. While for participants 1, 2, and 3, the intercept suggests that when there is no bits, no uncertainty, the manipulation of completing the task with one eye had a slower reaction time compared to the baseline when completing the task with two eyes. For participant 4, the slope of the baseline and manipulation were similar, suggesting that completing the task with one eye versus two eyes had a similar rate at which uncertainty is resolved. While the intercept for the baseline had a slower reaction time compared to the manipulation, suggesting that completing the task with two eyes resulted in a slower reaction time compared to completing the task with one eye. And this is the opposite to what we found in participants 1, 2, and 3. And these results for participant 4 are not what we expected, and this may be due to individual differences and or co-founding variables. Additionally, when looking at the patterns of the linear regression, participants 1, 2, and 3 showed interactions. The manipulation of completing the task with one eye had an inhibitory effect. The inhibitory effect of the manipulation was increased as task difficulties increased. Participant 4, however, showed no interaction, and again this may be due to individual differences. For participant 1, 2, and 3, the manipulation of completing the task with one eye had a slower reaction time in milliseconds compared to the baseline of completing the task with two eyes, thus suggesting that the manipulation did have an overall effect on the speed of the system. Participant 4, there was a small difference in reaction time for manipulation and baseline. However, manipulation and baseline were very similar. Therefore, manipulation did not have much effect on the speed of the system, and this may be due to individual difference. For participants 1, 2, and 3, results showed that the manipulation of completing the task with one eye did have an impact on the information processing rate, as participants were able to process more bits of information in the baseline condition, completing the task with two eyes, compared to the manipulation condition, completing the task with one eye. Participants 1 and 2, for baseline to manipulation, there was a reduction of the information processing rate by more than half. However, for participants 3, the reduction from baseline and manipulation information processing rate was even greater than participant 1 and 2. This result may be due to individual differences of the participant and or other co-founding factors. For participant 4, there was a slight difference in information processing rate. However, overall the information processing rate was very similar, thus suggesting that the manipulation completing the task with one eye did not have an impact on the amount of bits of information that can be processed. This may be due to individuals of the participant and or other co-founding factors. Participant 4's results was unexpected and inconsistent to the other participants' results. This may be due to individual differences. Participant 4 was left-handed, therefore completed the task with his left hand and covered his right eye with his right hand, while participants 1, 2, and 3 were all right-handed and completed the task with their right hand and covered their left eye with their left hand. Additionally, participant 4 wore glasses, therefore had a visual impairment. These individual differences for participant 4 may be the reasons for his unexpected and inconsistent result. It is recommended that future research should control for these individual differences, as it is suggested that they are likely to have co-founding effects on the experiment.
Our hypotheses that Fitt's task trials carried out with two eyes will on average result in a faster reaction time in processing information when demands of the task gets harder, compared to one eye, was supported. Although the ability to score highly on a Fitt's test is in itself inconsequential, the effects of using one eye rather than two on perception and performance, supported by the Fitt's test data in this experiment, have practical implications for tasks involving visual information and reaction time in the real world. If the speed at which an individual is able to process visual information and thereby react to this information is slowed down by this, highlights the potential dangers of sight difficulties, specifically one-eye blindness. This knowledge could be of benefit in understanding the effects of visual impairments and how it may implicate tasks, such as driving a car. The effects of such implications displayed in our experiment are consistent with Johnson's and Keltner's 1983 study, which supported that car drivers who suffered from binocular visual field loss had significantly higher motor vehicle collisions compared to those without any loss, suggesting that individuals with visual defects can impair driving performance. We recommend that future research should consider such implications, particularly in tasks requiring visual processing.
That concludes our video. Thank you for watching.